Welcome to this video on fractions. What is a fraction? A fraction is part of a whole. A fraction consists of two parts, the top part called the numerator and the bottom part called the denominator. The denominator or bottom number tells us how many pieces something is cut into. The numerator or top number tells us how many of those pieces we have. Let's look at an example. So take the fraction 2/5 or 2 out of 5. What does that mean? So if we draw a picture, we can use a circle divided into 5 equal parts. So it's important to understand that when we're talking about fractions, we're always talking about pieces or parts of exactly the same size. So what this is saying is that this whole piece, this whole circle, has been cut into 5 equal slices or pieces or parts. Then notice that 2 of those 5 parts are being shaded, so 2/5 means literally that I have 2 out of 5. Let's use the example of pizza to illustrate fractions. So suppose we have 2 different pizzas that are the same size. However, one of the pizzas is cut into 2 slices or halves, while the other pizza is cut into 3 equal pieces. I know this is not a traditional way to cut pizza, but this will really help us understand fractions. So let's go with it. So let's say that you eat half of one pizza or one slice from the first pizza. So again, you eat one slice out of 2 possible slices, or 1 out of 2. Again, remember 1 is the number of pieces that you ate, that's 1, right? And 2 is the number of equal-sized pieces that the pizza has been cut into. Then your friend also eats one slice, but from the other pizza. Again, the 1 tells us that the person ate one slice of pizza, and the 3 tells us that this pizza has been cut into 3 equal-sized slices. So did you both eat the same amount of pizza? Pause this video, think about your answer, and then unpause it. You didn't eat the same amount of pizza because clearly, even though you each ate one slice, those slices, those pieces are not the same size. In order to be able to compare the amount that each of you ate, the pieces of pizza that you ate had to be the same size. It doesn't make sense to compare them when they're not the same size. The same is true if we want to count the number of pieces eaten. In other words, how much pizza was eaten in total? Well, we could express this, or we could try to express this, by adding 2 fractions. Again, one person ate half of a pizza, the other person ate a third of a pizza. But how can we add those together? Well, sometimes students want to do this. They say, well, 1 plus 1 is 2, and then 2 plus 3 is 5. Let's see if that makes sense in the context of what we understand now about fractions and what they represent. Well, 2 is the numerator, and that tells us how many pieces were consumed. It is true that 2 different pieces of pizza were consumed, so maybe that's valid. But then let's look at the denominator. The denominator tells us how many pieces of pizza the pizza has been cut into. So remember, one pizza was cut into 2 slices, the other one was cut into 3 slices. Does the number 5 or 2 plus 3, does that have any physical meaning in our example? And it doesn't. It absolutely does not. It doesn't make sense to add the 2 or the 3. Again, one pizza was cut into 2 pieces, the other pizza was cut into 3 pieces. Okay, that doesn't make any sense to add 2 plus 3. Okay. Also, you might notice, and hopefully you're a little bit uncomfortable with adding 1 plus 1, because again, if I add this thing and this thing, right, I'm not counting the same thing. You know, the expression apples and oranges. Well, that expression means that you can't compare or count things that are different, right? If I want to count something, I need to count something that is exactly the same as other things. So I might say I have 5 apples and 6 oranges. So again, here, I can't add my numerators or my denominators. I can't really do anything with this expression right now, okay? Because again, our pieces are not cut into the same size slices. So what are we going to do about this problem? Again, we need to do this problem. We need to add 1/2 and 1/3, and we can't just add across. This is not doesn't make sense mathematically, and it also doesn't make sense physically to say that 2/5 of a pizza were consumed. It's very clear that, for example, 1/2 is already bigger than 1/5. So if you ate 1/2 of a pizza and then 1/3 of another pizza, you're clearly eating more than 2/5 of a pizza. So our two denominators, right, are 2 and 3. So what we need to do is we need to figure out a number that is evenly divisible by both 2 and 3. Physically, what that means is that we need to have pizza slices that are in the same size. So that means I have to cut this pizza up a little bit more, and I have to cut this pizza a little bit more until all the slices in both pieces of pizza are the same size. Okay, that's what finding a common denominator does. So our new denominator, when we divide by 2, has to give us a whole number, not a decimal or fraction. Also, when I take my new denominator and divide by 3, it also has to give me a whole number. So in school, you might have learned a lot and spent a lot of time on the least common denominator, but we're not going to worry about the least common denominator. We're just going to find a common denominator. And the fastest way to do that is just to multiply 2 by 3, or whatever your denominators are. So let's try that in the next page. So 2 times 3 is 6. Well, does that work? Well, 6 divided by 2 is 3. So that satisfies our condition that 6 divided by 2, right, has to be a whole number. It also satisfies our condition that that number divided by 3 is a whole number. So let's see what this means physically for our pizzas. So again, I start out with a pizza that's cut in half, and half of it was eaten. So what I could do is I could multiply this whole fraction by 3 over 3. What that means is that I take each half of the pizza and I cut it into 3 slices. So now I have 1, 2, 3, 4, 5, 6 slices, right? So then if I were to eat half of that, that means that 3 out of the 6 slices would be removed or consumed. Let's look at our other pizza. Again, we have 3 slices over here, or 1/3, right? 1 out of the 3 slices is getting eaten. Well, what do I need to do to each of these thirds? Well, what I need to do is I need to cut it in half so that it looks like this. So what that does, it gives me 1 times 2 is 2, 3 times 2 is 6. So we can clearly see that 1/3 is the same as 2/6. So now, finally, at long last, these pizzas look the same except for the number of pieces that were consumed. And now that the pieces or the slices of pizza are exactly the same size, now it actually makes sense to count 1, 2, 3, 4, 5, and we could say that 3 out of 6 plus 2 out of 6 is 5 out of 6. Again, now I can add them. I can compare them because everything matches up. It's all the right size and they're all uniform. So I could say that 5/6 of one pizza was eaten, or I could say 5 slices of pizza were eaten. So it looks like we're all done with this problem. However, I want to take a little bit more time to clarify how we knew what to do with each of the two fractions in order to get the right denominator. So remember, we got 6 simply by multiplying the two denominators together, 2 times 3. So for each fraction, what we're asking ourselves is, what is missing from our denominator? So 1/2, what do I have to multiply 2 by in order to get 6? Well, I need to multiply 2 by 3. 2 times 3 is 6. So I multiply by 3 over 3. Now, if you're wondering, well, how is this legal? How am I allowed to do this? Well, the reason is that 3 over 3 is just 1. And I can multiply anything by 1, 1/2 times 1, and it does not change that fraction. It actually completely stays the same. So since I have a 3 upstairs and downstairs, I am not changing the value of this fraction at all. I'm just getting an equivalent fraction. So I get 1 times 3 is 3, 2 times 3 is 6. Likewise, on the other side, well, how did I know to multiply 1/3 by 2 over 2? Well, again, I'm asking myself, 3 times what number is 6? And the answer is that 3 times 2 is 6. So we multiply by 2 over 2. And again, the reason this is a completely legal math operation and it doesn't change anything is because 2 over 2 is simply 1. And 1/3 times 1 is still itself. So I can get 1 times 2 is 2, 3 times 2 is 6. And again, right, 2 over 6 could reduce to 1/3. I can always go back to my original fraction because these are equivalent fractions, 1/3 and 2/6.